So we're not going to do a ton of stuff today. Hopefully that's okay. No? You guys want to do a ton of stuff? That's my check to make sure you guys are actually listening. That's fine, Jeff. Do that anytime you want. Don't too much. Yeah. Yes, you can. Don't worry. So you need to. Did you email me? Yes. Okay. So there's a couple of you have to take it. So as soon as I make a makeup, there's a few people that still need to take test 1 too. So I still need to make makeup for that. Anything out of the ordinary for me is always pushed to the back burner. So as soon as I get one made, I'll let you know who to call and where to go.
Okay.
Cool. All right, guys. Let's get back into chapter 4. Really, all I want to do today is finish up 4. Because then chapter 5 is where we get into decimals. There's a few things in 4.7 that we still have to finish up. So let me just throw an example at you here. All I asked for you to do on the test was to kind of convert mixed numbers to improper fractions and vice versa. But we really didn't look at operations with mixed numbers. And so something like this, 2 1/4 plus 4 3/8. This one's not 2 either. What do you still have to do here?
Are we solving it, or you want to?
We'll do it together. Yeah, I have to still get an LCD.
You have to.
So why is it called a mixed number first? Why are these called mixed numbers? True, but why do they use that word mixed?
Because it's mixed with your whole number and
Good. It's a mixture of, guys, it's a mixture of a whole number with fractional parts. That's why we call it a mixed number. Yep, so on 2 1/4. So again, if you like this way better, it's fine. I've got to change this one. The 2 stays the same. That's not going to change worth anything, but 1/4 is also known as how many eighths? Because you got to make it eighths, right? Good, times 2. 2 2/8 plus 4 3/8 is exactly what you would think, hopefully. 6 5/8. Right? 2 plus 4 is 6. 2 3 is 5. Sweet. Now just to give you an option, and this option will actually make, guys, this option will actually make some of the difficulties easier. Fruit. If you change these first into improper fractions. This particular problem wasn't that hard, but I just want to show you on this one how you get the same answer no matter what you do. How do I change this into an improper?
Times by
add
4.
it times it.
Yeah, 4 times 2
8,
plus
9,
1.
9 fourths.
Good. Guys. 8 times 4. 32 plus 3.
35.
35. So this makes further problems easier because now it's a little more compact. Right? So now I can still do 9 fourths plus 35/8. I still want to change this one. Times 2 times 2. And what do I get when I add those? So it's 18 plus 35. What's 8 plus 35?
43.
43 plus another 10. 53. 53 over 8. And if I had to, I could change that back into a mixed number. 8 goes into 53 6 times. That's 48 with 5 left over. It's still the same answer, of course. Cool. So let me show you a case where that helps.
So if we do it that way, that's okay.
It's fine.
Oh, okay.
So watch this. Here's where things get really strange. Guys, I'm gonna break you up. Keep saying I will and I will. Here's where things could get strange. If I had 7 1/4 minus 5 3/4. Can you guys see why there's a strange element here? And it's really not easy to take care of if you don't know what you're allowed to do. Can you tell me, identify, what is it that's difficult about this problem? Yeah, this fraction is not big enough to take away 3/4, is it?
Alright, so you got to take.
So what do we do,
from the
for
seven.
example, what do we do here?
You take from the 7.
Let's make this more interesting. If I had 61 minus 39, what do we do here, of course? This is actually 60, isn't it? So that's why if I make this 50, I can put the extra 10 there. I don't know if you guys have ever heard it explained fully, why you're allowed to steal that 1. It actually is 10, so that's why that becomes 11. So that's old news.
So you-
But
so you
here,
can take from the 7.
yeah, I can take a whole 1,
4/4.
4/4. I love it. If I take 1 away from 7, that's 4/4. That becomes 7 5/4. Not 7, Jack. 6, thank you. Thank you. So it's really the exact same idea, if you think about it. I took 1 away from 7, but 1 can be thought of as 4/4. So now I've kind of overloaded my fraction piece. Why did I have to do that? So I can subtract this guy. Same thing here. I overload my 1's place, so I can actually handle that 9. It's exactly the same idea. All right, so you guys are like, stop. So here I get 6 minus 5,
Yeah,
1 and
2, 4.
2/4, which is 1 1/2. Now I'll tell you this. I'm okay with you doing it either way, but if I ask you, use mixed numbers. You have to. So don't think you can get away without knowing how to do this. I could very easily ask you to do specifically this. But let me show you, what would this look like if I did it like I did that first one, that second way? If I change these first into mixed, into improper fractions. What's that as an improper fraction?
29.
Yeah, 29/4.
29/4.
And this will be 23/4.
Minus.
And see, there's not the problem anymore, is it? So you really, if when you do this, you take this idea to the extreme. You overload both of them. Just overload the whole damn thing. This is kind of like, you don't have to do that, just overload it a little bit. This is like, screw it, just go the whole way. Overload it like crazy. And then what's 29/4 minus 23/4? 6.
That's, 6.
6/4, which is 3/2, which is 1 1/2. Same thing we got, thank God.
Oh.
Okay. All right, how we doing? Is that all right?
It's a lot better.
What's up?
Making them into fun questions seems like
Oh, yeah.
easier than not to miss.
So I'm not gonna ask you like a ton of those, but I am gonna probably ask you to do one of these.
Oh, that
Just
is.
to demonstrate you could do it, but then the rest of them I'd leave open, so that I'd rather much do it this way. Yeah. Yes,
This is the easy way.
this is right.
Yeah.
Good.
Why you vote this?
Hmm?
This one.
Because this is showing that you really understand how fractions work.
Because he said just kick back and let the.
Now, of course, if I cut everything out of a math class that was hard, we wouldn't need to meet.
He said just kick back and let the others learn what they need to know.
I know. All right, so what's the operation here? Multiplication. Now, here's the thing about this. If you think you could just do 3 times 5 and then 2 7s times 4 9s, let me really show you what's going on with this problem. What is 3 and 2 7s? What the hell is that? When we say and, 3 and 2 sevens, what operation is that?
A mix.
I know it's a mixed number, I know what we call it, but what is it mathematically? Adding. This is 3 plus 2 sevens. You with me?
It's not different.
I want you to stay with me now. I'm going to show you what you would never, ever do on this problem, and then show you what you would. All right? I got to break the habit, because it's really easy to think I could just do 15 and 8 63rds. You see where I got that? That's wrong. That's why I didn't write it down, of course. All right? Because 3 and 2 sevenths is 3 plus 2 sevenths. 5 and 4 ninths is 5 plus 4 ninths. So what do you actually have to do here if you wanted to be crazy? You'd actually have to FOIL that thing. I know we haven't talked about it officially yet. But you'd have to do this. Distribute, 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 distribute. Screw that. You with me so far? And why is it? I still haven't done that problem, but give me a second. Why is it that I can do this directly? What do I get when I do 3 times 2? 6. And what's x times x squared? How many x's now? X cubed. There's no plus sign in there, is there? It's multiplication, so it's all multiplication. I can multiply whatever order I want to, and so of course I multiply the numbers together. Here, this is addition. Oh shit. I need foiling to kind of help me break order operations to do this distribution stuff. I never want to do that. So of course, on this problem, I would only ask you to do it, I erased it, the way where you make it in proper fractions. Then there's no problem. You've taken like 2 pieces and put them into 1. So then you just have fraction times fraction, not a big deal. So what is this as improper?
21,
Good.
22.
23? Yeah, 21 and 2. And then this one, 49 over 9. And unfortunately, well, fortunately, I'm really hoping I get everybody on board with this, looking to see what reduces first. So you don't have to do 23 times 49 and get that big ass number. Don't do that to yourselves. 7 goes into 49.
7.
1.
So 23 times 7 over 9.
161.
Good, 161. All right, cool. How we doing?
And if you want us to put it back into
All right.
a number.
So let me say something real quick before I go insane. Guys, if I am talking about something and I'm in a section that you totally understand, and you desperately need to have a conversation with somebody sitting near you, there's the door. Go out. All right? If you are talking about problems or something, I understand that. That's cool. That's better. But still, if somebody's sitting near you and you're talking, they're not going to be able to hear what's going on. That's frustrating. So please, while I'm lecturing, keep the talking down. When I stop and let you guys do problems, you can talk about those problems as much as you want to. Right? Please stop making me feel like an old man driving a car with a bunch of kids in the back seat. Okay, I don't like that feeling. Do not do that.
Turn this equation around.
Oh man, and you know you're in trouble when you start making math jokes. All right. Let's see. So that's basically that section. Adding mixed numbers, subtracting mixed numbers, multiplying, dividing, and of course division is just multiplication. You just flip the other 2, right? Yeah. Okay, let me show you one last thing that's a little freaky. That's not making it too freaky.
But then I got stuck. Maybe 15, yeah.
Now, on first glance, this does not seem too freaky. This looks really easy, and it is. The first step is easy, right? What's 8 plus 4?
It's 12.
12. 2/3 plus 2/3.
4/3.
Now, there is a problem with that answer that we can correct easily. What's the problem with this answer?
4/3 is a number.
This is like an uber mixed number. It's a whole number and an improper, no, it has to be a mixed number or improper. You can't have an overloaded little dude here.
But if you have that class, figure them out and then
Would you
put them
turn
back
into
together.
improper?
You could. Well, what's 4/3? How much does it have too much of? I mean, it's got a whole 1 in it, right?
Right. You got-
So I can take that whole 1, 12 and 4/3.
and
It's
one-
12 and 3/3 plus 1/3. So I can take 1 away from this and put it on there and make that 13. And then I got that extra 1/3 still there. Now, of course, from the beginning, you can make it improper and then not even see that.
Right.
So again, if you from the beginning make them improper, you should be able to do it. But again, your evil teacher might ask you, do this problem, leaving it as mixed numbers. So you have to know how to handle that. So if I ended up with an answer, if I did a work and I ended up with 7 and 10, what, Jeff? 10/3. This is a good one. What's the slight difference here? What's the whole piece out of 10/3?
3.
Good. You guys see that? There's a 3 in there with an extra what?
1.
1. Because 3 goes into 10 3 times.
Yeah.
So this number can become
8. I mean.
10.
10.
Because there's 3 in here, isn't there? So if you really break this down, here's a way you can do this if you want to do it very specific way. Change 10/3 into a mixed number.
It's 3.
It's 3 and-
3 and 1/3.
So then 7 plus 3,
It's 10.
there's 10 and 1/3, there you go. Now some of you guys could probably handle the shortcut, pull the 3 out, make that 10, and then there's 1/3 left, there it is. Or you could write it specifically, make that mixed, and then put them back together. But you have to handle this problem somehow, don't just leave it like that.
Right.
You'll lose some points. All right. So let me give you guys a few to try real quick before we get to the next section. Those aren't too evil.
Last one, 7, 2, over 4, or 9.
9.
9.
What I find really funny is y'all are the quietest at the times that I said you're allowed to talk. One last one here. So I put one more up there for you to try, a little more easy.
I tried.
Number 2 is evil because it's a little big.
And I probably get it wrong.
You can handle it.
I just did all this work for nothing.
What do you mean? Oh, you started off with the wrong thing?
Don't even look at that. Wait, that's what I just did. I just erased it all. Just wrong, and then you wrote up what I just did. Damn it.
No, it's fine. I'll probably do
Oh, yeah, it's 5, so 16, 24.
Okay.
Okay.
Yeah. Oh, yeah, yeah. Yeah, I've seen that one. The other one's kind of stupider than that is, man, go solve your own problems.
Did I do that one?
Yes. If this was 6 times 1/4 and 7 times 2/9, that would be fine. But it's actually 6 plus 1/4 and 7 plus 2/9.
Wait, why?
Because it is.
Okay, that's fine.
Is that all right? Really?
Yeah, that's really fine.
Cool.
As long as I don't need to
It
know
never
why
works.
for any reason.
Because it is.
But these don't reduce.
Yeah, no.
Did you say yeah, no?
No.
Okay. I think
I
that's
was
right.
agreeing with you and then saying, yes, you're right, they don't.
Okay.
So
That's why I
yeah,
stopped,
so
because
yeah,
the
no.
systems are really big. Okay, so this means you don't wanna do improper functions, because then they get really big.
You have to do it properly. Yeah. Okay. So this first one's not too bad, right?
No.
So this you can keep as 5 and 7/9. This one you have to make 3 and what?
6/9.
6/9.
Yeah.
So then you get 5 minus 3,
2.
2 and
1/9.
1/9. Is that okay? So it started you off nice, like we always do. And then we immediately go into, what the hell, but 25 to 65 is 1625. Because there's nothing that cancels here, is there? No. 4 times 9 is 36. And if I wanted you to make that into a mixed number, here's a trick. Do 1625 divided by 36 in your calculator. It's going to come out with a decimal, isn't it? And all I want is the whole number part.
So it's gonna be 45 and then whatever.
So 45?
36.
So 45, now what's 45 times 36?
1620.
1620, so that must mean there's 5 extra.
5, 36.
Let me say that again. If you do 1625 divided by 36 in your calculator, you get 45 point, You get 45-point mess, right? That's, well, you could. If you could. Is there anything, if I can't reduce here, I cannot reduce at the end, of course. Here I can see their parts better. There's nothing that reduces between here, is there?
No.
No. So of course there's nothing that's going to reduce here because this is made of those numbers. So if nothing can reduce there, nothing can reduce there. Cool. And then you just have to kind of, if I want to change it into a mixed number, that's one trick. When you have this ugly fraction, do the division. Do the division. Take the whole number part. Now what's 36 times 45? 1620, which means that 5 is the extra. That 5 is the extra. Maybe. All right. You're not going to see that too often, so don't freak out. But that's what you do if you did see that big ass number. So what about this guy? First step is pretty easy. Maybe. What's the first step?
Times 2.
Yeah, so multiply by 2.
91.
11 and 6 sixteenths. Minus 7 and 15 sixteenths. Right? So then you could, if I forced you to, if I said do this with mixed numbers, what could you do with this guy? Borrow 1 from him, and 1 can become anything over that thing. So it would become 16 sixteenths. So this is now 11, oh, you keep doing that, Jeff. 10 and 22 sixteenths minus 7 and 15 sixteenths. Now I can handle that. 10 minus 7, 3. 22 minus 15, 7. Or, you know, if I didn't say, you could just make these both improper. Funny thing about that is they get pretty, well, semi-large. Not crazy big. Yeah.
Yeah, I get the same answer, but I ended up with 4 and negative 9 sixteenths, so I knew to drop the 4 to a 3, and then I just put the remainder on top of this.
I like that, and it's sort of, this is sort of not conventional fruit. This is sort of not conventional, but you can figure out what this means.
Yeah, so I knew it was 3.
So you have to take, you can take a negative 1 away from this and put it here to make that 3. So if I take a negative 1 away, I'm actually kind of like adding 1 to this, and then that means to me was 7 sixteenths. Now if you don't like that, definitely don't do that. I like that you saw that, and if it makes sense to you, you could really do that every damn time. If it doesn't make sense to you, then never do it. Right? That kind of makes sense. That's the nice thing about math, having a few different ways to do it. You can pick the one that makes the most sense. If none of them make any sense, then come see me.
That's not it.
All right. How are we doing with that? Is that decent enough? Okay. I don't know if any of you guys, I'm afraid that some of you guys might know that your calculator might have a fraction button on it. If you don't know that, now you do. So when I don't see work done, some of you guys got points off, even though you got the right answer, but there was no work. I will take points off if there's no work, because you have all these other ways to get the answer. I have to see the work. If you know how to use your fraction button on your calculator, you can check your work. Sweet. But do your work in the first place. All right, so one last section in 4, and then we're going to get out a little early. Yes, I am nice to you and me. I don't know if my dean watches my video, so hey, dean.
They don't.
No, they don't.
They have no view.
They have too much else they're supposed to be doing, and maybe doing. Oh,
Yeah, let's just get all this on video.
yeah. Let me start off. We've already seen section 4.8 is all about how to solve equations with fractions in them, and we've already seen one case. The simplest case of this would be something like that. We saw something like that on the test. And really, this isn't even, you don't even think of it as a fraction. It's x divided by 5 equals 3. I do the opposite operation, so I'm going to multiply. So then I get x equals 15, cool. So let me take the next step up from this. The next step up from this would be if I didn't just have, if I had something like 2/5 x equals 3. Now that certainly looks a little more like it's got to be looked at as a fraction. And there's two things to take care of here. What do I mean by that? Here, there was one thing to take care of. Just the 5 was with the x, so I can take care of that by itself. Here, I still have the 5, and it's still dividing, so I would still do what to kill it?
So you would multiply.
Multiply.
2/5.
I'm getting there. So those would cancel, but what do I have to do with that 2 to kill it? So let me do this in 2 steps, and then I'm going to do it in 1 step. So right there, is everybody cool with just that step? That's the exact same step we needed here just to kill that 5. Now those cancel. And what do I get? Yeah, 2x, 15. And then the last thing I do is divide by 2. Good. So a quicker way to do that same problem. And that wasn't really a long problem, but you can imagine if this is part of a bigger problem, I want to do every piece quick. So if I have the same problem, I think I heard somebody say this, I could do this multiplication and this division all at once. If I multiply, it's 5 times that. If I divide, it's 2 on the bottom. So can't I just multiply by 5/2?
Yes.
Multiply by the reciprocal. That might sound familiar. If I multiply both sides by the reciprocal of this guy, and you can put that 3/1 if you want to, just to make it look more like a fraction. Do you see how over here what happens? The 5s cancel and the 2s cancel. And that's exactly what you want. You want that x by itself. And what happens on the other side? 15/2. Same answer I got there. Cool. Okay, baby. All right, so now, you gotta get used to this. Now we take the next step up, right? We started with the basic. We took 1 step up, let's take another step up. Let's ramp this thing up a little bit. What if I instead have this? So notice one thing. This is very similar to the first problem if I took that minus 1/3 away. Right? It's the first problem I just had to multiply by 5. So if only that 1/3 wasn't there, it'd really be the same steps as the first problem. You guys with me? A little bit? But now I got a little bit more on that side, shall we? There's 2 main ways to do this. I'm going to show you the way that I suggest you do it. And then if you don't like that, I'll show you a different way you can do it. And we'll see if anybody wants to do it that way. The easiest way to do this, and help me out, why did I multiply by 5 here?
Because you're trying to cancel out.
Yeah, the only fraction had a 5 on the bottom, so I just have to multiply by 5. Why would multiply by 5 here not really take care of my whole fraction problem?
Because they're two fractions.
It would kill this guy, right?
You still have 1/3.
Yeah,
I
you
still
don't
have this guy there. It would cancel a little bit here, but I'd still have something left there. That sucks. So I want to multiply by something that will kill all the fractions. You with me? Let's kill them all. And that thing is going to be the number that has all the pieces in it. And that number, of course, we already know it. It's the LCD. So if I just get the LCD of all the fractions in my equation, I can multiply everything by it and they all die. So what is the LCD? 15. Careful, it's got to be the number they can all multiply up to be. Right?
It's like serious about that 5.
I know. So if I multiply each thing by 15, so multiply this by 15, and real quick, the reason I'm doing that, the reason I'm allowed to do that, the reason I have to do that, is if I multiply one side by 15, I have to multiply the other side by 15. So to tell you honestly, this is the way it would look. I don't need all that. Out there. You guys with me? But then what do I have to do with this 15? And that's trying to be a 3 there, that's a neat job. What do I have to do with that 15?
Distribute.
Distribute it. So I just say from the beginning, multiply each piece by 15. So you don't have to kind of remember to do that. Just multiply each piece by 15. You can put it over 1 so it looks more like the fractions that it's trying to act on. Now that looks ugly at the moment because we just loaded up everything with something else. But what happens right after that? 5 goes into 15 3 times. 3 goes into 15 5 times. And 15 goes into 15.
1 time.
Yay. So on this side I get 2. Here I get 3x minus 5. Do you guys see that? Shit. Just look at each piece. Is this cool? 5 goes into 15 3 times? Let me do this again.
I can't write it down and have all these X's through it and not know where I started.
Don't worry.
Let me start over.
This is where I gotta get used to more colors. So if I multiply everything by the LCD, multiply 15 times this, I'll put it over 1 and make it look more like a fraction. Right? So that's what I'm doing to both sides, is multiplying by 15. Marcy, right? And again, why am I multiplying by 15? If I'm a student in math, if I'm allowed to make the fractions go away, tell me. Please tell me how to do that. Right? Even if I'm really good at math, fractions are still a place that it's easier to make a mistake. If they're not fractions, you're not going to make the same mistakes you would.
You can erase it.
Huh?
Just erase it.
What do you mean? Oh, yeah, I don't know either. Maybe not the best way to go with that.
Cancel it out.
Yeah. So I want you to realize it's really the same idea here. I multiply by 5 because that would kill the fraction. 5 is not good enough here. So I have to multiply by a little bit more, so it makes sure to kill everybody. So if we multiply by 15, what do I get here? 5 goes into 15.
Yeah, I get all of that.
3
I got
times.
lost in those all these.
3 x. 3 goes into 15. So minus 5. And 15's cancel, so equals 2. Now that looks so much better than that. But they are actually the same equation, they just look different. They are the same exact equation. So now this is easy, should be. Right, add 5,
7/3.
divide by 3. And I get a fractional answer, but I don't care because I'm done. So let me show you a second way to do this. And this other way, normally students don't like it as much, but maybe some of you guys will. It's never 100% don't like it. If you like that way, maybe stare at the wall here for a minute.
You know today's 10, 11, 12? I just thought I'd point that out.
Oh, yeah. So 10, 11, 12, 123. 123 on the,
What?
all right, screw.
Yes.
10, 11, 12.
1, 2, 3.
At the time, 123. That's the time that math people geek out. So
That's why you're learning it now,
you guys
right?
with
You
me.
have somewhere to go.
Just like March 14th is Pi Day. Yeah, we all put on shirts, we march down the streets. You need to. We want better representation in TV shows. We're not all super geeks. Yes, we are. So the other way to do this is to not kill the fractions. To just start solving like we normally would. Here's my x, right? So don't I want to get rid of this minus 1/3? So I would add 1/3 to both sides.
I don't like this.
So you get x over 5 equals, now you got to do this times 5 times 5 to get the LCD. So 2 15ths plus 5 15ths,
So,
7 15ths. And then the last thing I have to do is multiply by 5, right? So I get x equals 5 goes into 15 3 times, I still get 7/3. So I went through that a little quickly because I could sense that most of us don't like that way. And I don't blame you, I don't like that way either, tell you, I could do it, hopefully, I teach math, that's what I do, but I would much rather do this way. The more I do, the less I have, the more I know, the less I have to do, and I can make it nice, whole number problem, sweet. Much better. But if anybody likes that way better than this, feel free, please do it. It's beautiful, I love it, do it that way. So the last kind of problem I want to show you, and then we'll head out, is the one place. Now, in full disclosure, you could use cross multiplication in more places than this if you were comfortable enough with mathematics. If you knew where things should end up, there's more things you could do. This is the one official place that you can cross multiply safely and not have to think about any other weird, clever things. This is just directly straightforward. If I have something like this, because, and here I'm going to show you why cross multiplying works. How would I kill that 9? What would I do to both sides to make that 9 cancel? Multiply by 9, right? Wouldn't that make that 9 go away? Stay with me. All right, see that 9 goes away. How could I kill that x? Multiply by x on both sides. And see that x goes away? Are you semicolon? I know I've kind of loaded it down a little bit, but multiply by 9. It ends up over there, doesn't it? Because you got to do the same thing to both sides. Multiply by x, it cancels, it ends up over there. So see, the shortcut is 9 times 7, because that's what I'm going to do anyway. Cross multiply 63, cross multiply 2x. So cross multiplication is a shortcut to solving equations with 2 fractions in them. One fraction equals another fraction. You can't do it when I have 3, because then who goes to what? Screw it. You can only do 1 fraction equals 1 fraction. Do not do cross multiplication anywhere else to keep yourself safe. One last step here, of course.
5 by 2.
Sweet. All right, so that's the end of chapter 4. Next time we're going to get into decimals. Oh,
I don't want to give it back.
Because it's more similar to the other way that we've been doing it, you know.
Definitely not gonna do that.
So I didn't even know you were trying to go there. So Kelly tried to follow me out with the dog at the vet. I told her that I didn't think that was because I didn't realize at the time.
Wrote.
Yeah, and that wasn't really planned. And I didn't want her to feel, she felt she had to stay. And I don't blame her, because she's gotta be here. So in the future, you gotta make that appointment earlier, make that appointment more in the future. And then I can just send it directly, and then you just go directly there. So there's no problem. So I'm sorry about when I heard, I was hoping you were like,
I'm free. More time because I need to think. I can't think about it.
in the future, just make it earlier, because then I can get it there for you in the first place, yeah.
Exactly.
Yes.
Yes. Those are just a bonus, so you don't lose any points.
But all these errors, how do I still get them?
Because again, like I said, I doubled everything at first and then cut it in half, because then it gives me more.
I try to be self-sufficient.
There were like 30 questions roughly, so they each would have been worth like 2.5 or something points. That would drive me crazy. So I just double all the points, gives me more room for partial credit and cut them in half. So when I say -2, it's actually -1. So whenever I say -1, I would have had to do -1/2, and I just don't like it.
Or we walk in there, you know, it's like awkward, like we're guys, and we try to avoid like close proximity, you know. Girl,
Did you email me?
Yes, I did.
You did, so don't worry, as soon as you get the makeup done, I'll let you know who you call and where to go.
Thank you.
Oh, thank you. Doing what else? So, what I could do is, if you have time, or if you email me, I could tell you where your grade would be if you made corrections to like that second test. Did you make corrections to the first test? So I could tell you, because you're allowed to make corrections, and it would take your grade up. So I could tell you what your grade would be if you made corrections. Plus, if you get all the homework turned in, your grade's gonna go up. Right? So, I mean, it's not impossible. The quickest way to pick up your grade is to make corrections to the test. Because if your test grade goes up, your grade's gonna go up a lot faster, because it's a big percentage of your grade. And we still have a couple more tests, and we still have the final, and we still have more quizzes.
I'm okay with that.
So as long as you do relatively well on those, your grade should continuously go up and up and up.
Okay, and I know that,
You?
test number 2, because,
Me too.
when I was
Me too.
gone, I had asked you if I could.
And my last one
take it.
wasn't so hot, so.
I might, so I.
Well, my previous ones were like.
No, no, you're fine. Like I was telling them,
95
there's a
and
few other people that
100, so I
didn't
didn't
make
worry
it,
so
and
much.
they,
And then I'm
emailed
gonna make
me.
corrections so it's gonna go up.
Testing, yeah.
no pressure.
And here's for 5.1.
I'm just into my 2 homework.
But we should not doing better this
Sure.
class, which is surprising for me.
For me, I have this for like 8 years, and that is not.
Math has never been my forte.
Yeah.
And same here.
Okay, good.
Alright, I'll see you
So that's what I need, is just, human error mostly. That's where I have my notes page. I didn't print out my notes page. Shoot. Oh, look, the old notes page with the other day, I hand out. Can I hold over this? Sure. Okay. Okay, thank you.